Hello and welcome to IC&D1 Lab 6, finding all subnets of a network with less than 8 subnet bits. This video shows how to find all the subnets of Class B network 128.200.0.0 with mask 255.255.224.0. Also, if you're using the Cisco Press exam certification guides, this video is best used while you're reading IC&D1 Chapter 12. This video focuses on a particular process to find a few things about a network number. In particular, this process shows how to find all the subnet numbers of a single classful network, as well as identifying the two subnets that are special, the zero subnet and the broadcast subnet. A broader goal for this video is to be part of a package that helps you learn how to answer CCNA subnetting questions, in particular to teach you how to answer those questions quickly and with confidence. This particular video shows how to find all the subnets of Class B network 128.200.0.0 using mask 255.255.224.0. Now, for those of you that are also using the Cisco Press books, this video demonstrates one of three processes that are used inside those books for finding the subnets of a single network. Those three processes make three different assumptions. The first assumes less than 8 subnet bits. The second assumes more than 8 subnet bits, and a third process assumes exactly 8 subnet bits. This video demonstrates the process that assumes less than 8 subnet bits, and by the way, the book refers to this process in a summary appendix as process RP7A. The video image now shows a copy of the 6-step process that's demonstrated in this video. I'm not going to go through every step in the process here generically. Instead, the rest of the video will demonstrate how to find all the subnets using these steps. Also, if you'd prefer, you can get the booklet that came with this product and refer to this 6-step process in that booklet. Next, let's take a look at the example. In this example, we'll use IP network 128.200.0.0, which is a Class B network, and mask 255.255.224.0. That means there are 16 network bits because it's a Class B network, 3 subnet bits, and 13 host bits. Now, in process RP7A, the first 4 steps occur only once, and step 5 is then repeated. So, taking a look at the first 4 steps, first we see that we simply copy down the mask into the top row of a table. Then at step 2, we put a box around the interesting octet. Once again, that's the octet in which the mask is not a 0, nor is it a 255. At step 3, you calculate the magic number. The magic number is 256 minus the value of the mask in the interesting octet. In this case, 256 minus 224, or 32. Finally, at step 4, you just write down the classful network number, which is also the exact same value as the 0 subnet. Next, to find each successive subnet number, you simply keep repeating step 5 of this process. In step 5, you start out by copying the 3 boring octets, the ones that are outside the box, down to the next subnet number. Then you add the magic number to the previous subnet number's interesting octet's value. Now visually, you just take the magic number 32 that you see there, add it to 0 in this case, which gives us a value of 32 in the interesting octet of the next subnet number. So as you see here, the next subnet number is 128.200.32.0. To find the next subnet number, you simply repeat step 5. So at step 5A, you copy the 3 boring octets down to the next subnet number's line, and then at step 5B, you add the magic number of 32 to the previous subnet number's value in the interesting octet, which is 32 in this case, for a value of 64. So the next subnet number is 128.200.64.0. Repeating step 5 again, we copy the 3 boring octets down to the next line in the table at step 5A. And then at step 5B, we add the magic number of 32 to 64 in this case, which gives us 96 for the new subnet number. So this next subnet number is 128.200.96.0. At this point, you should start to see the pattern. Of course, in the third octet, all the subnet numbers are some increment of 32, which is the magic number. So going through the rest of these subnets briefly, for the next subnet, if we add 32 to 96, the next subnet number's third octet is 128. For the next subnet, the third octet's 128 plus 32, or 160. For the next subnet, the third octet is 160 plus 32, or 192. And yet for the next subnet, the third octet is 192 plus 32, which is 224. Now we're close to the end of the table, and as you might guess, we're almost to the end of the process. At this point, we just keep repeating the process, copying the 3 boring octets to the next line, adding the magic number of 32 to the previous subnet number's value. In this case, we get a value of 256 as this last subnet number. Now, even if you didn't know much about the process shown in this video, you'd probably think that the value of 256 is a strange number in an IP address or a subnet number. Normally, you'd expect to see numbers between 0 and 255 inclusively inside a dotted decimal IP address or subnet number. As it turns out, step 6 of this process uses the fact that we add up a value equal to 256 as a reminder to say, stop the process. So here at step 6, notice it says that 256 is a value that's out of range, so let's not use that subnet number. In fact, in this case, we'll just put a big red X over it. Then, the previous subnet that we had calculated, the one that ends in 224.0 in this case, happens to be the broadcast subnet, which is the last of the 8 subnet numbers in this example. So that completes the example of how to use the process that assumes less than 8 subnet bits to find all subnets of a classful network. Now you can remove some of the clutter from your workspace if you like, and you can even write down the numbers as dotted decimal numbers as you see here, noting always that the 0 subnet is the smallest number of these subnet numbers, and the broadcast subnet is the largest of these. Now as you see here in this particular example, there are 8 subnet numbers listed, and it's a good reminder to think about how many subnets are listed because, as we said earlier, there are 3 subnet bits, so we should expect to see 2 to the 3rd subnets at the end of this process. In summary, this video shows how to find a classful network's subnet numbers, assuming the same mask is used throughout the network. The process also identifies the 0 subnet and broadcast subnet, as well as it uses no binary math. Because of that, it makes it a great tool for finding the answers to subnetting questions on the CCNA and CCNT exams because you'll go more quickly and you'll be able to find the answers with much more confidence.